Good day, students. Welcome to another video lesson about statistics and probability. So for today's video, we're going to discuss the mean and the variance of a discrete random variable. Objectives for today: at the end of the lesson, you will interpret the mean and the variance of a discrete random variable. You will solve problems involving mean and variance of probability distribution, and you will illustrate a normal random variable and its characteristics. And by the way, our references for this video lesson came from Maomat YouTube channel, and this is the YouTube link. So first activity, what is the formula? I will present some situations and you will identify what formula is most appropriate or most applicable for that situation. So let's review what are the formulas that we've discussed so far about the mean and the variance of a discrete random variable. First formula is mu of x. So what do you mean by mu of x? It is the average, okay, or the mean of the discrete random variable. Okay, so for our second formula, so this sigma squared. So what do you mean by sigma squared? Okay, so sigma squared is for the variance of the discrete random variable. Okay, so if we want to compute for the variance of the discrete random variable, we will use this formula. So it is the summation of the square of each random variable times the probability. Okay, then after getting the total square root of the random variable times the probability, then you will subtract to the square of the mean of the discrete random variable. So let's have formula number 3. So again, this is for variance, but it is another way of computing the variance. You will subtract the random variable to its mean. Then you will get the squared. Then get the summation. Then after that, you will multiply it to the probability distribution or to the probability. You will multiply it to the probability or px. Formula 4, your sigma doesn't have the square anymore, and on the other side of the equation, you have the square root of x squared times the probability of the random variable, then minus the mean of the square of the mean. When you are computing for the square root of the variance, then you are computing for the standard deviation. So this formula 4, is the formula for the standard deviation of discrete random variable. Those are the 4 formulas that we will use in this activity. What's the formula? So let's proceed. So what is the situation? Situation 1, I am thinking of finding the average number of heads that would appear if I will toss 2 coins together twice. So which formula should I use? Kindly pause the video and try to answer on your own. Okay, so do you have your answer? If you are thinking of finding the average, that is your keyword average. So which formula is most applicable? Formula 1, Formula 2, Formula 3, Formula 4. Of course, the correct answer is Formula 1, which is your mu of x, or the mean of the discrete random variable. Formula 1. Situation 2. I went to the grocery store and I noticed that there are 5 different kinds of brown sugar at different prices. Each brand has different probabilities that they will be sold. What formula should I use if I want to determine how the prices vary from the average price of the product that will be sold to the customers repeatedly? Okay, did you understand the situation? So when you're dealing with word problems or situations, so you must have comprehension and analysis. Based on your understanding, okay, so from the word prices vary from the average price. So that is your keyword to identify which is the most appropriate or applicable formula to use. If the researcher wants to know the variation or the prices how the prices vary. Of course, you will use the variance formula. Or, specifically, if you want to be specific, the comparison to the average, you will get also the standard deviation, which is the square root of the variance. How the prices will vary to the average price. Okay, clear? So the answer is standard deviation. Of course, you cannot get the solution of the standard deviation if you do not get the variance first. That is part of the process in getting the solution or in getting the answer for the standard deviation. First, get the variance, then get the standard deviation. So for our next activity, activity number 2. So let me read the situation. Suppose an unfair die is rolled and let x be the random variable representing the number of dots that would appear with the probability distribution below. So far in our previous discussions, when we talk about die, it is a fair die. So for this situation, the die is declared as an unfair die. So let's see the probability distribution table and why is it an unfair die. So before we answer the situation, let us check if the table gives us a discrete random variable. So the outcomes of our die is 1, 2, 3, 4, 5, 6. And the probability px is 0 0.1, 0 0.1, 0 0.1, 0.5, 0.1, and 0.1. If you're going to get the total of the probability, it will give us a total of 1. Let us check why is it an unfair die. We know that if the die is fair, the probability must be 1 over 6 or in decimal 0.16666 approximately. Okay, so each outcome, it must have a probability of 0.16666, okay, approximately. But if we will going to check the probability of getting a 4 dots, it has a probability of 0.5. The die is biased to 4. Okay, so what is the question? What will be the average number of dots that would appear? We will use what formula? Use the formula for the mean of discrete random variable mu of x. So how do we get mu of x? Yeah, so mu of x is the summation of each random variable times the probability. 1 times 0.1 plus 2 times 0.1 plus 3 times 0.1 plus 4 times 0.5 plus 5 times 0.1 and plus 6 times 0.1, and it has a total of 3.7. So what do you mean by 3.7? So the average or the mean of the discrete random variable is 3.7. If you're going to round this off, it is closer to 4. The mean of the probability distribution is 3.7. Since the mean is equal to 3.7, we can say that the average number of dots that would appear is a number near to 3.7, which is 4, because the die is not fair or an unfair die. It is biased to 4. Okay, so let's proceed to question number 2. We will use the same table or the same situation. Number 2, how does the assumed value of the outcome vary from the average number of dots that will appear? So from the word vary, okay, so we will use the formula for variation and standard deviation. So first, solve for the variance. And the formula for the variance is you will get the summation of x squared times the probability. Okay, so get the square of each random variable times the probability times its probability, then get the total. Then after getting the total or the summation, you will subtract the square of the mean. So the answer is 1.81. So you can double check it using your calculators. You can check if the answer 1.81 is correct. So 1.81 is the variance. So to get the standard deviation, so that we can compare it to the raw data, okay, variance is in squared. So we cannot compare a squared value to a linear value or in degree of 1. So our raw data degree of 1. So we will get the square root of the variance, which is the standard deviation. Okay, so square root of 1.81 is 1.35. So what does 1.35 means? It is the variability number of outcomes. So 1, 2, 3, 4, 5, 6. How it will vary to the average. So what is the average? 3.7. So with respect to the average, which is, or the mean, which is 3.7, so the movement of our normal distribution graph or the bell curve will be 1.35 to the right, and to the right of 3.7, and 1.35 to the left of 3.7. So let's have our conclusion. So small variance or standard deviation means that the assumed values or data points tend to be very close to the mean. Higher variance or standard deviation means that the assumed values or data points are spread out from the mean. And the variance and standard deviation measures or describes how far a set of data assumed values of random variables is spread out. Okay, did you understand? So small standard deviation or variance meaning the data is not dispersed or it's very close to the mean, while higher variance or standard deviation means the data are dispersed or spread out from with respect to the average or the mean. Is that important? Of course, it is important because the mean or the average is our standard. If the data are dispersed from the standard or it is scattered from the average or the standard, so therefore the data we cannot predict, or the outcome is more reliable when the data is close to the average. So I will give you an example. If you have a business and you want some investors to invest in your business, so as an investor, they want to invest to a business which has a stable income or profit. Okay, so for example, your average income of your business is 1 million per month. Okay, so that is your average. So compared to other business that their average is scattered. Sometimes it is 100,000, sometimes it's 300,000, sometimes it's 2 million, sometimes it's 3 million. So the data of their monthly income is scattered. It is spread out. It's not concentrated in the average or in the middle, which is comparison to the other company. It is concentrated to 1 million. So as an investor, you want to invest in a stable company, right? When you want to invest your money or you want to buy some shares to your in their company. So you want a stable business. So let's proceed. Since the value of the standard deviation is 1.35, we can say that the assumed values of each outcome are somewhat close to the mean for about 1.35 units from the mean. Okay, so the distance from the mean. So from 3.7, so the distance to the next standard deviation. So that is one standard deviation away, so 1.35 units. So let's proceed. So the first data in the following examples is somewhat expected to have a higher variance and standard deviation or variability compared to the other data. So I will give some situations and examples. We will analyze why is it that the first data a higher variance and standard deviation or variability compared to the other data. Okay, so let's analyze. So first situation. So example number 1, the population size of 100 different countries around the world compared to the population of 10 countries belong to the first world countries. So example number 1 is comparing the population size of countries around the world. So that is the first data. And it consists of 100 different countries around the world compared to the population size of 10 countries, only 10 countries that belongs to first world countries. Okay? So, therefore, the higher the population or the sample size, the more the variance, the higher the variance or the standard deviation or the variability of what you are getting. Yun. Let's have example number 2. The number of students in different universities compared to the number of students in a class in a particular school. So obviously, you have higher variance and higher standard deviation or variability with the number of students in universities compared to the number of students in a class. So it ranges from 30 to 50 students compared to the number of students in different universities. So the population of each university, how much? Hundreds, thousands. The variation and the standard deviation and the variability is very high. So let's have example number 3. The number of people who love to play basketball in different barangays compared to the number of basketball players from different teams who play in the first quarter game. The number of people who love to play basketball compared to the number of players, basketball players. The comparison of the first data and the second data, obviously the first data has higher variance and standard deviation or variability compared to the other data. Clear? So therefore, the mean, variance, and standard deviation are very important in statistics because they serve as the basis for other types of statistical calculation or statistical tests. If you have any questions, clarifications, also you will give your learnings for today's discussion, kindly answer our Google Forms evaluation in our Google Classroom. That's all for today, and God bless.